Chapter 12, Lesson 2, Statistics and Parameters. You're going to find out that a lot of this, if you took Course 3 last year, you've already talked about these statistics. Statistics and parameters. Now, this is a little bit different. It's, again, more vocab, just like Lesson 1 was. Statistics are just of a sample is used to make a conclusion about the entire population. So, again, you're going to use statistics from samples when the population is so large you can't possibly include all of them in the calculation. So you use a sample to find the statistic and assume that in making an inference that you could apply that to the entire population. So a statistic is a measure that describes a characteristic. So a parameter is a measure that describes a characteristic of a population. So statistic, characteristic of a sample. A parameter is a measure that describes a characteristic of a population. So parameters are fixed values that can be determined by the entire population, but are typically going to be an estimation based on carefully chosen samples because, again, almost impossible to calculate it with every single member in a population. So statistics can usually vary from sample to sample, but hopefully if it's a good sample, it doesn't vary a lot. A parameter, on the other hand, will never change because it represents the entire population. So the first part of this lesson is really kind of some wordy things. So we're going to identify a sample, then we're going to identify a population, and then describe the statistics and describe the population parameters. So let's look at this first example. A random sample of 10,000 high school students from Virginia was asked for the average amount of time they spent using a computer each day of last week. Okay, so the sample are 10,000 high school students from Virginia. Okay, the population would probably be all high school students from Virginia. Okay, so the sample statistic would be the average time each of the 10,000 students spent on a computer per day, or /week, doesn't really, each day of last week, okay? And the population parameter would be the average time all students in Virginia. The average time all high school students in Virginia spend on a computer each day or week. I say day or week because they're not very specific. They just ask them how many times each day of last week. So maybe they're doing it by day, maybe they're doing it by week. They didn't actually specifically tell us that. Okay, so notice this is very, very similar. It's like almost the same exact thing. It's just understanding the difference between the sample and the entire population. So let's try another one. A stratified random, there's some terms from last lesson. A stratified random sample of 2,000 employees of fast food restaurants in Indiana are selected. The median number of days that the employees have, and the median number of days that the employees have worked at the restaurants is calculated. The median number. So the sample are the 2,000 employees. Employees of fast food restaurants in, where are we at? Indiana. Oh, I think it's IN. Okay, maybe you guys know that. Don't tell me if I'm wrong, because I hate to be embarrassed, okay? So the population would be all fast food employees in the state of Indiana. Okay, the sample statistic is the median number of days worked for the 2,000 members of the sample. And the population parameter would be the median number of days worked for all fast food of Indiana. Okay, for all of them. Okay, so just understanding the difference between a population and the sample, and that, remember, a statistic is from the sample, a parameter is from the entire population, and typically, depending on the size of your population, typically your parameter is found using statistics from samples, because it's just sometimes impossible to calculate, okay? So moving on, what kind of statistics? We're going to be more specific, and we're going to talk about statistical analysis. Okay, way back at the beginning of the year, you probably don't remember, but we talked about univariate data, measures of central tendency, mean, median, mode. We talked about it in the last lesson too. Univariate data can also be represented by variation to assess the variability, meaning how much the numbers vary. Okay, so we can talk about it using a range, quartiles, interquartile range, mean absolute deviation, and standard deviation. Now, I know you did that in course 3, and it's not tough, but I know you did it. It can be annoying because there's quite a few steps. So let's first talk about the one that you did in course 3, the mean absolute deviation. It is the average of the absolute values of the differences between the mean and each value of the data set. Now, so there's a couple steps you got to do, and we are going to calculate this. All right, so turn to the second. Here's a step-by-step calculation. So understanding what those things mean, it might be different. So first find the mean, and that's how they represent it, like the X with the sort of bar over top of it. You know how to find the mean, add them all up, divide by how many you have. Then it says find the absolute value of the difference between each data value and the mean. Meaning, you go to each number in your sample or number in your group, and you find how far away it is from the mean, like the distance from the mean. And then you add them all up and divide by the number in your mean. So you basically find the mean of those distances then. Okay, so you find the mean two times. So let's do this one, okay? In example 2, we were talking about pets. Avery kept on track how much she spent on her guinea pig supplies. On each trip to the pet store, she spent the following amounts, rounded to the nearest dollar. So 4, 12, 3, 5, and 6. So first find the mean. We're going to add all 1, 2, 3, 4, 5 of them up. So 4 plus 12 plus 3 plus 5 plus 6. So that total is 22, and we're going to divide by how many we have, which is 5. So 22 divided by 5 should give me 4.4, or $4.40, correct? Now, we're going to find the distance, the absolute value difference that each of these is away from our mean. You know, notice I put it to the nearest penny because we're talking about money. Okay, so $4. How far away is $4? Well, that's 40 cents away. How far away is $12? Well, 12 minus 4, 40. gives me $7.60 away. $3 would be $1.40 away. Whoops, wrong spot. $1.40 away. $5 is simply 60 cents more, and $6 is $1.60. All right, so finding all of those. Step 3 and 4, we're going to add them all up and divide by 5 again because we have 5 numbers. So first add them all up. So 40 cents plus 7.60 plus $1.40 and 60 cents and $1.60 is $11.60. I hope that's right. I'm going to double check. Okay, I got it the second time, so I'm hoping I'm right. Divided by how many I have, which is 5. And so when I do that, again, I'm going to round to the nearest hundredth because I'm talking money. $2.32. Now, what does this mean? You have to understand that when you, besides just calculating all of this, it actually tells you something. It tells you that the average distance, distance each amount is from the mean of the data. So on average, on average, the distance that each amount is from the mean of the data is $2.32. Well, our mean was $4.40. So given that our mean absolute deviation is about half of our mean, that's pretty spread out data. It's pretty spread out, okay? But that's the mean absolute deviation. Find the mean, find the distance each number is away from the mean, find the mean of that, and write your sentence, okay? Standard deviation was not something that you calculated last year, and there's a reason for that. It's more steps, okay? It's very similar because, again, find the mean, find the difference from each value. The difference here is now we're going to square each of those. You're going to square each of those. You're going to add them all up, then divide by the number, and the very last thing is take the square root. So the added steps in there is squaring each one, adding them up, dividing, and then the last one added step, square root. Why you do that, I'm not going to lie to you. I am not exactly sure. I'm going to go out on a limb and say it's probably going to be a better measurement, different measurement, maybe better in terms of, I think it's maybe incorporating a little bit of the Pythagorean theorem, but I didn't look that up. I'm just shooting in the dark. Hopefully I'm right. And if you want to know, you can always Google that and work it on your own and read in there. But I'm not going to overthink it, overanalyze it. I'm going to use the calculation, and I'm going to calculate it. Okay, so let's do this. We got another example. Variance and standard deviation. So the word variance refers to the sum of all of them before you before the answer you get before you take the square root. Okay, so let's first find the mean. So we have, Ed surveys his classmates to find out how many electric gadgets each one has in their house. I'd hate to know how many. I'd have to, it would take me a while to add mine up. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. I know I have 15 numbers. We're going to add them up. So we've got 9, 10, 11, 6, 9, 11, 9, 8, 11, 8, 7, 9, 11, 11, and 5. That poor soul, he's only got 5. So I got a total of 127, 7, and divide it by 5, or 15. We get a mean of, I'm going to go ahead and round this. I get 8.46 repeating. So just because this is going to be a mess of numbers, I'm going to round it to 8.5. But you know what? Just to be sure, I want to just sum it. I'm going to do it one more time because I want to make sure I have the right number before I do all my calculating, because that would be a lot of calculating for nothing. 8, 7, 9, 11, 11, and 5. 125 divided by 15. Now that time I got 125. 10, 11, 9, 8, 11, 8, 7, 9, 11, 11, 5. Oh my goodness, guys. 9 plus 11. I mean 10 plus 11 plus 6 plus 9 plus 11 plus 9 plus 8 plus 11 plus 8 plus 7 plus 9 plus 11 plus 11 plus 5. I've gotten a different answer every single time. Oh goodness. So hopefully you've calculated it by now. 10. 9 plus 10 plus 11 plus 6 plus 9 plus 11 plus 9 plus 8 plus 11 plus 8 plus 7 plus 9 plus 11 plus 11 plus 5. 135. You know what? It's the second time I've gotten 135. And I'm going to use that because I think that the book probably did that on purpose, because 135 divided by 15 is 9, and that's going to make our life way easier. So 130, 135. So that's our mean. That is our mean. Now we're going to find out the difference between each of those and 9. So that first one is going to be 0, 1, 2, 3, because 6 is 3 below. 9 is going to be 0, 2, 0, 1, 2, 1, 2, 0, 2, 2, and that 5, 4. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, just making sure. I'm going to find the square of the differences. So 0 is still 0, 1 is still 1, 4, 9, 4, 1, 4, 1, 4, 4, 4, 16. Notice I didn't include the zeros because when I square them, it's still 0, and I'm going to add them all up. So 5, 14, 18, 19, 24, 28, 32, 36, and 16 gives me 52. Divided by 15 gives me 3.46 repeating. And then I'm going to take the square root of that. So this is called the variance, or approximately 3.5. And the square root of that would be 1.86. So what does that mean? Again, that means that the average distance each value is from the mean. That is not what it means. That would be the mean absolute deviation. It just means if I compare this right here, 1.86 to my mean, what this means is because the standard deviation is small compared to the mean of 9, the values are, what's the word I want to use? The values are more compact they're closer together. They're all grouped tightly. And it's true. I mean, other than the 6 and the 5, you know, it only goes from 7 to 11. They're all very tight together. Now, if your standard deviation was, you know, about the size of your mean or maybe half your mean, that tells you that, you know, hey, your values are quite spread out. In this case, it's not. So, and I like the way that they word it down here. The standard deviation measures how concentrated, that's the better word, that was the word I was looking for, the data are around the mean. The more concentrated, the smaller the standard deviation. So this standard deviation was pretty small because they were all pretty close to 9. Okay, so here are some properties that can help you when you're interpreting this. So it's never going to be negative because when you square it, it's going to be positive, and that's good because distances are never negative. The smallest possible value for the standard deviation is 0, and that happens if every single number is exactly the same. That means there's no deviation. It doesn't change. It's the same number every time. Okay, it is very much affected by outliers. If you have an extremely low or an extremely high number, it's going to affect your standard deviation because it affects the mean. If you have an outlier, it really skews the mean, either below or above. Okay, so if it's going to skew the mean, it's going to skew the mean or the standard deviation because it's based on the mean. And the units are always going to be the same as the original data. So in this case, we were talking about number of electronics. But if we're doing like an average temperature, it would be degrees. If you're doing money, like we did on the front side, it would be dollars and cents. So there's something else to look at. Okay, let's do a couple more. I know we're getting along here. So you can probably fast forward to the end and see how it goes. And see if you get the same. So if you want to pause me now and fast forward to the end, you can do that. And see if you get the same answer. Okay, so I'll just do it as I go here. So let's see. We've got 81 and 78 and 79 and 82 and 80, 80, 79, 83, 81, and 80. And I am dividing by 10, so I get 80.3. Okay, so standard deviation, so 80.3, I've got, let's see, 0.7 squared, it's 0.49. See how it is much more difficult when you don't have integers. That first example gave us integers, super nice. This one, not so much. 78, and we square it, which would be 5.29. 1.3 squared would be 1.69. 82 minus 80.3. Square it. 2.89. 0.3 squared is 0.09. 0.09. 1.69. 83 minus 80.3 squared gives me 7.29. 0.49 and 0.09. Okay, I'm going to add them all up. So 0.49 plus 5.2 plus 1.69 plus 2.89 plus 0.09 plus 0.09 plus 1.69 plus 7.29 plus 0.49 plus 0.09 and divide by 10. It is 2.01, and what are we talking about? Golf course, so strokes. Now, if we compare that, so his mean is 80.3, and his standard deviation is 2.01. I'd say he scores all pretty close together, because compared to your mean, that's a very small number. All right, so that's at Table Rock, but at Black Hawk, his scores look a little more spread out. Let's see, we got 84, 79, 86, 78, 77, 88, 85, 79, 87, 86. So divided by 10, we get 82.9. Definitely not as good on this golf course. So minus 84, let's square that. We get 1.21. 82.9 minus 79. Square that, we get 15.21. 86 minus 82.9. Square that. 9.61. 80.9 minus 78 squared gives me 20.01. 1, 2, 3, 4, 77. So 82.5. 82.9, excuse me, minus 77. 34.81. 88, didn't have one of those yet. Doggone it. 82.9 minus 88. We're going to square that. 26.01. 82.9 minus 85 squared. 4.41. 8.9 minus 79. 15.21. 16.81, and the last one, 9.61. And we'd have to add them all up. Divide by 10, and then take the square root. Oh, biscuits. I don't think I took the square root of this one. Did I? Oh, man. Yes. No, I didn't. 0.49 plus 5.29. Plus 1.69, plus 2.89, plus 09, plus 09, plus 1.69, plus 7.29, plus 0.49, plus 0.09. I did not divide by 10. I forgot to do that. I apologize. So this is not right. It's even smaller than that. It is 1.42 strokes. So very good, even closer. All right, so let's compare that to this one. Okay, so 1.21 plus 15.21 plus 9.61 plus 24.01 plus 34.81 plus 26.01 plus 4.41 plus 15. 10. Okay, and I get 3.96 strokes, which is not a surprise because these numbers are more spread out than those numbers. Now, 3.96 is still small in comparison to the 82.9, so it's small in comparison to the mean. So it's still a pretty tight, compact group of numbers. However, it's not quite as tight as this one. And that makes sense. I mean, just look at the range alone. It goes from 79 to 83 is all, where this one goes all the way from 77 to 88. Much bigger range, okay? Now, I'm going to stop that one there because we are already at a half hour, and I hope you fast forwarded through all that mess but got the same answers. And I'm going to attach another video to show you how you can actually use your decimals calculator to calculate standard deviation. All right. So good luck. You have an assignment. It is 1 through 13 and the worksheet, which hopefully doesn't freak you out too much, especially after you watch the next video.